Hi, welcome to question 8 of the Leaving Cert Ordinary Level 2025 Paper 1. So we'll get stuck straight in. As always, worth reading the question carefully, maybe multiple times, and giving it a go yourself and see what strategy you come up with. I'll read through it now. A company launches a new phone. The company's profit each year will depend on the number of phones it produces, and they're calling that X, the number of phones it produces. The company's profit for the first year can be modeled by the function P of x is equal to negative 1.5 times x to be squared plus 10.5 times x, take away 4. Now, if you see this, this is actually a quadratic function. I know that because the largest power is a 2, so it should follow a quadratic pattern. Now, they say that P of x is the profit for the first year in millions of euro, and x is the number of phones in tens of thousands it produces in the first year. It's saying there with x is greater than or equal to 0, but less than or equal to 7, and x is an element of R. Now, from my experience, this can really put people off, but they're just trying to be descriptive, trying to be mathematical in their language. Don't overthink it. Your x value can be any number. It could be a fraction, decimal, whole number, negative number, whatever. Okay. And it's just saying x is between 0 and 7. That's really all it's saying. You really don't probably need it, so we'll see if we do, but I don't think we will. Now, part 1 says find P of 0 and explain what it means in the context of this question. Now, if you see here the P of x and the P of 0, if you make the leap, they're saying find the answer when x is 0. That's literally all they're doing. Okay. So I write out my original function. Okay. Now I always like to put the x kind of slightly lower. This is not p times x, which I feel is something that a lot of people kind of make a misconception about because we often, drill into people that brackets mean multiply. And they're kind of going, "What's p times?" So it can be as a source of confusion. Okay. All I'm doing is putting 0 in everywhere I see x. Now that will cause this term to go away and this term to go away. And all you're left with is a negative 4. Now, what does that mean? It means that if no phones are produced, there will be a loss, okay, because it's a negative number. And this could be like due to research costs, setting up production costs, all that kind of stuff. Okay. Now, part 2 says complete the table below to show the value of P of x for any given value of x. I already know the answer for P of 0. Okay, it'll be negative 4. But they do give me some answers already built in. Now, I realize that this is actually just is one we found. I just never got rid of it in the animations. So I do a sample calculation. I'm using P of 1, okay, just to test it, okay. I would show a sample calculation maybe separately, just if I was doing myself. And when 1 goes in, okay, instead of x, the answer is 5. So this is the right strategy. So again, I have it for 0 from part A. I do it for 2, 3, 4, and 6 and 7. Okay, and I get my answers. And that's it. Okay, so just calculator work. You can just keep backspacing, change the number inside the brackets, and get all your answers. Okay, it's good to show a sample calculation because if you don't and you make a mistake, all your answers will be wrong. And that will have like a pretty severe penalty in that you might get 0. Okay, now you might get -4 because you've done the calculation up here. You might get the low partial. Now, part 3 then says draw the graph of P of x on the axis below for x is greater than or equal to 0, is less than or equal to 7. And again, that's just the range as such the domain, I should say, the domain we have for x. Okay, so don't worry too much about it. Now, I'm just plotting. So the first one there, when it's x is 0, it's -4 on the y. Okay, so should have it there. Then when x is 1, the y value is 5. Okay, when x is 2, the y value is 11. When x is 3, the y value is 14. Now I'm getting all these from the table down here, and I screen grabbed it in from the answer in the previous part. When x is 4, y is 14. When x is 5, y is 11. When x is 6, y is 5. When x is 7, y is -4. Now, I keep saying y, even though the question hasn't mentioned y, but something to always note about function notation and graphing is that this P of X is Y. We just are using function notation, so that can be a bit more confusing. Okay. I draw my graph. It's not drawn with straight lines. It's a kind of curve. I'm trying to draw that there. Didn't do too bad a job. It didn't do too good a job, but it's rough and ready. As long as you have the points there and your graph is running freehand through them in a curve, you'll get full marks. Now, part 4 says, use your graph on the previous page to estimate the range of values of X for which the company will have a profit of at least 6 million. Show all your work on the graph. So I copy the graph in, okay? So we're looking here for where there's a profit of 6 million, okay? So it'll cut across the whole way and it intersects with the model at 2 points, okay? And we're trying to find the range of values of X. Okay? So we're from basically saying from here as far as here. That's the range. Okay, now it's not quite 1. Okay, I'm estimating that to be 1.2, and maybe I'm off. Okay, but there's a tolerance, and then it maxes out here at I'm saying 5.8. Okay, so you just can read the value down below it. Now, part B says the profit of the company for the second year can be modeled by the function q of x is equal to 1.5, so negative 1.5 times x squared plus 9.6 times x, take away 3.5. It says where q of x is the profit for the second year in millions of euros, and x is the number of phones in tens of thousands it produces in the second year, with x being between greater than or equal to 0, less than or equal to 7. And again, x is a real number. That means it can be any number. So lots of terminology there you probably don't need, but always worth reading just in case. Really, this is what we're focused on. Okay, it's a different model. Okay, similar but different model. Then it uses this weird symbology here. Find q prime of x. Basically, that means find the derivative of q of x. Okay, now if you recognize that terminology, this means differentiate. Okay, so we're going to differentiate this function, and whatever we get will likely be our answer or very close to our answer. Okay, now there's my my function written out. Okay, now when I differentiate this, the rule for differentiation, there's a whole pile of rules, but we're using the power rule here. Okay, and you're multiplying the power by the number in front. So 2 times negative 1.5 is negative 3. Step 2 of the power rule says you should take 1 away from the power. 2 take away 1 is 1. Okay. Now, hopefully, if you don't have a kind of grasp of that power rule and differentiation, what I'm saying there might seem absolutely crazy. I would strongly suggest you seek out another video just to get those basic rules. Differentiation can go and become really tricky the more advanced you use it, but it is such a cool technique for looking at change in a system, which is what we do as humans, not just in science or engineering. We're always observing change, but we as a species have managed to make that exact, and we've built all this. Okay. Now the second term here, the plus 9.6 times x, there is a power of 1 here. So following the power rule, 1 times 9.6 is 9.6. And then you're taking 1 away from the power, which gives you x to the power of 0. And one of the rules of power states that anything to the power of 0 is 1. So you're ending with 9.6 times 1, which is just 9.6. Now the negative 3.5, we learn off that any number when differentiated, the slope of it is 0, because a number is horizontal to the x-axis. So there is no change. It's always negative 3.5. So what's the measure of its change? 0. Okay, so it just goes away. And that's it. Now, part 2 then kind of leads on, and this is something you should be expecting to see in the exam paper, a max or min question. And there is a 4-step method to follow to do it. And step 1 is differentiate the function you have. We've just done that, okay? And then we move on, okay? We use that. Now, the weird thing about slope is that it's a measure of change. The one place I know is that at the maximum, the slope of that change is 0. It's not going up. It's not going down. It's 0. And that therefore I can state that. Okay. Now, if you cop it, this happens all the time in maths, this q prime x and q prime x are the same thing. Now, if they're the same thing, doesn't it logically follow that these are the same thing? And once you make that leap or you remember to realize it, I can put those statements equal to each other. Now, this is an equation of one unknown. So if I use algebra to solve this, I can find out what x is. Now I'm going to I want to get rid of this negative 3x. So I'm going to add 3x to it. That will do the job. But I'm only correct if I do the exact same thing on the left-hand side, the other side. Now, some people just move it across and change the sign. That's totally cool. It's the same thing. It's just a slightly faster way of doing it and moving it across. Now, these cancel out. Okay, so I've gotten rid of it. That's why I did it. On the far side, I end up with 3x is equal to 9.6. Now, I could divide both sides by 3 to get rid of the 3, or move the 3 across and divide it. Or, that might be a way of finding it out. Or you could kind of ask yourself, 3 times what number gives 9.6? And a fair number of people might cop that that's 3.2. Okay. So I now know my x value, okay, but I want to find out what the maximum value is, so I need to know what the y value is as well. Now, we said it in a previous part, but q of x means y. We just don't state it in the question. So this is what y is. So y is given by this jumble of x's. Now, I'm looking for y when x is 3.2. So I need to swap out everywhere I see x with 3.2. And then when I put that through the calculator, it will give me a value of y at that point. Okay, and that's my answer. Okay, the x value is 3.2. The y value, okay, is 11.86. Now, it's a bog standard question. Might be a lot of words in this particular one, but knowing the four-step method for max and mins is vital. And the four-step method is whatever function or equation you're given, differentiate it. Put that answer equal to 0, solve, put that answer into the original equation, you're done. Okay, so it's predictable in that it will most likely will come up. When it does come up, if you can kind of make an effort at doing that, you can score pretty well in this question. Now, that's part B, part 2. Okay, now part C says the profit for the third year can be modeled by the function R of x, where R of x is the profit for the third year in millions of euro, and x is the number of phones in tens of thousands it produces in the first year. With x being an element of R, which means it's a real number, it says the graph of R of x is shown below for the domain 0 is less than or equal to x is less than or equal to 6. And again, just state that again, x is an element of R. So if you think about it here, as the x value increases, as time happens, okay, the value of the profit goes up and up and up and up and up and up and up, okay, and eventually levels off. And then even though this is still profit, they're making less profit, okay. Now it's still profit, and it's only not profit down here in the negative part. And this is just as x gets bigger, y changes. And this is a quadratic pattern. Graphing can be tricky to understand. That's all it's really representing. It's just a visualization of what the model is. And we see different patterns, linear patterns, quadratic patterns, logarithmic, exponential, trigonometric, etc. And they help to describe the world around us. So they're testing, do you get this concept? Okay, and you have to interpret the words they're asking and not get overly confused and bamboozled. And there is a lot of words. I would suggest, and it's a flaw of mine, but read the question a few times. You may feel like, oh, I'm so whatever for having to read it 3 times, 4 times. But the times I don't read it 3 or 4 times is when I just miss something and then I answer a question. I think I'm doing great. I might never know I got it wrong, or I might catch it and then fix it, but I put you on the back foot. So let's read it. At the start of the third year, the company receives 3 million in additional funding. As a result, the profit for the third year can actually be modeled by profit is equal to this function plus 3. Okay. Then from the graph, it says estimate R of 2 and hence work out the value of R of 2 plus 3. Now, R of 2 means where is x equal to 2? And that's here. Okay, so I read it up. I think I have it done in the, when x is 2, it hits the graph and I read it off as 8. Now to find the profit, okay, I have to add on 3 to that number. R of x is 8. Okay, I found that off from the graph, plus 3, which gives me 11. Now I set animations there, but they didn't play in the right order for some unknown reason. And that's part one. Now, part two says on the diagram above, draw the graph of y is equal to r of x plus 3. Remember, this is r of x. Okay, so plus 3 is just add on 3 to every value. So minus 4 plus 3 is minus 1. Whatever this is, 3.5 plus 3 is 6.5. 8 plus 3 is 11. And I just keep going around. Okay, join the points together, and that's the actual model of their profit for that year, because the 3 million was extra, so it's still matching the same graph. It's the same thing. It's just plus 3. Okay, and that's it. Now that's the end of question 8. So as always, if you want a copy of these notes, just send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. Best of luck.